Welcome back to my YouTube channel. Now we are going to solve very important questions from trigonometry, that is prove the following identities or prove that questions. Okay, so question number 6 from exercise 6.1. First question, prove that sin square theta upon cos theta plus cos theta is equal to sec theta. Now here we need practice to solve these examples, and in such examples we can solve the example using LHS first and coming to RHS, or by considering RHS we can prove LHS, like that. So there is not fixed method. So in this example consider LHS, that is sin square theta upon cos theta plus cos theta. ओके, एक्चुअली ये एग्जाम्पल्स बहुत ही इजी होते हैं बिकॉज हमें पता है दूसरे साइड पे क्या है, तो वी कैन सॉल्व इजीली. नाउ हियर denominator of cos theta is 1, and hence by cross multiplying we get sin square theta plus cos square theta upon cos theta. And we know the first identity, that sin square theta plus cos square theta is equal to 1. So we can substitute 1 for this numerator because it is identity, and hence it is 1 upon cos theta, and which is equal to sec theta, because reciprocal of cos theta is sec theta, and we got the RHS. So we have proved this identity. Okay, simple? Yes. Now next example from this is cos square theta into 1 plus tan square theta is equal to 1. Again consider LHS, cos square theta into bracket 1 plus tan square theta. Now you can easily tell that 1 plus tan square theta is equal to sec square theta. That is the identity. So 1 plus tan square theta is equal to sec square theta. So substitute sec square theta for this bracket, and hence cos square theta into sec square theta. This dot represents multiplication, and we know, actually we know cos theta into sec theta is equal to 1. But अगर आपको याद नहीं आ रहा है तो you can do like this. You can solve cos square theta into sec square theta. Sec theta is reciprocal of cos, so write like this, 1 upon cos square theta, and then cancel this is equal to 1, which is your RHS. Hence proved. Simple? Okay. Then next example. Under root 1 minus sin theta upon 1 plus sin theta is equal to sec theta minus tan theta. Again consider LHS, 1 minus sin theta upon 1 plus sin theta. Now here we are going to multiply numerator and denominator by 1 minus sin theta. 1 minus sin theta into 1 minus sin theta, and upon 1 plus sin theta into 1 minus sin theta. Like conjugate, multiplying both numerator and denominator by 1 minus sin theta to both. So numerator is 1 minus sin theta whole square upon, in the denominator see, it is like a plus b, a minus b. We know this identity, a plus b, a minus b, then that is equal to a square minus b square. So here in place of a we have 1, and in place of b we have sin theta, and it becomes 1 square minus sin square theta. So it is equal to 1 minus sin theta bracket square upon. Now see, from first identity, that is sin square theta plus cos square theta is equal to 1. I am writing here sin square theta plus cos square theta is equal to 1, we get cos square theta is equal to 1 minus sin square theta. So for this sin 1 minus sin square theta, we can write cos square theta. Now see, in root we have both squares, that is numerator and denominator both are square. So actually we can remove the root sign and write the square roots, that is 1 plus sin theta upon cos theta, and then separate the denominator. इसको separate करके ऐसे लिखो sin theta upon cos theta. Correct? Sorry, here it's minus sign, so write minus here. Yeah, so 1 upon cos theta is equal to sec theta, and sin upon cos theta is equal to tan theta, which is your RHS, and hence prove the identity. Okay, this is the next example. Sec theta minus cos theta into cot theta plus tan theta is equal to tan theta into sec theta. So consider LHS. Sec theta minus cos theta cot theta plus tan theta. Okay. Now write the basic values for all ratios, that is sec theta is 1 upon cos theta minus cos theta upon 1. Now cot theta means cos theta upon sin theta plus sin theta upon cos theta, and just simplify. इसको अभी क्रॉस मल्टीप्लाई करेंगे, डिनोमिनेटर्स आर डिफरेंट, सो क्रॉस मल्टीप्लाई 1 minus 1 into 1 is 1, cos theta into cos theta is cos square theta upon cos theta. This is first bracket. Then here also इसको भी ऐसे क्रॉस मल्टीप्लाई करो, दैट इज cos square theta plus sin square theta upon sin theta into cos theta. Okay, now here we are going to use the identity, only one identity, that is sin square theta plus cos square theta is equal to 1. So for this bracket, that is numerator of this bracket, we will substitute 1, and for 1 minus cos square theta, we have this sin square theta is equal to 1 minus cos square theta. So for this 1 minus cos square theta, we will substitute sin square theta. So here sin square theta upon cos theta into 1 upon sin theta into cos theta. Now sin square theta, that means sin theta into sin theta upon cos theta into 1 upon sin theta into cos theta. So we can cancel one sin theta for this, and then sin theta upon cos theta is tan theta, and 1 upon cos theta, that is sec theta, and which is our RHS. So we have proved this identity also. समझ में आ रहा है ना? इसको प्रैक्टिस करना पड़ता है, बहुत सारा प्रैक्टिस चाहिए इसको. Okay, good. Okay, next example is this cot theta plus tan theta is equal to cosec theta plus sec theta. Again here consider LHS. Cot theta plus tan theta, इसको अभी हम बेसिक रेशियोज में कन्वर्ट करेंगे, दैट इज कॉट थीटा का मतलब है कॉस थीटा अपॉन साइन थीटा, एंड टैन थीटा मतलब साइन थीटा अपॉन कॉस थीटा. नाउ क्रॉस मल्टीप्लिकेशन, जहाँ पर भी डिनोमिनेटर्स डिफरेंट है, सो वी कैन हैव दिस क्रॉस मल्टीप्लिकेशन मेथड. सो कॉस स्क्वायर थीटा प्लस साइन स्क्वायर थीटा अपॉन sin theta into cos theta. Now we know the identity, sin square theta plus cos square theta is equal to 1 upon sin theta into cos theta. Now we can write this as 1 upon sin theta into 1 upon cos theta. We can separate like this because 1 into 1 is 1. And now 1 upon sine theta is cosec theta and 1 upon cos theta is sec theta, which is our RHS. Hence proved. Our next example is this one. 1 upon sec theta plus tan theta is equal to sec theta plus tan theta. This is also very easy. Consider LHS. ये जो प्रूफ करना होता है उसके राइट साइड में भी हिंट होता है. अभी यहाँ पे देखो सेक थीटा प्लस टैन थीटा प्रूफ करना है जो कि न्यूमरेटर में है. सो मल्टीप्लाइंग बोथ न्यूमरेटर एंड डिनोमिनेटर बाय सेक थीटा प्लस टैन थीटा. हम ऐसा कर सकते हैं कि जो भी करना है दोनों पे करो, न्यूमरेटर और डिनोमिनेटर. सो 1 अपॉन सेक थीटा माइनस टैन थीटा इनटू sec theta plus tan theta and upon sec theta plus tan theta. Clear? Now 1 into sec theta plus tan theta is sec theta plus tan theta upon. Now here we will use the same identity. A minus b, a plus b, which is equal to a square minus b square, and here a means sec theta and b means tan theta. So we get sec square theta minus tan square theta. Now we know this 1 plus tan square theta is equal to sec square theta. We know this identity, and using this identity we can have this subform sec square theta minus tan square theta is equal to 1. So substitute 1 for this denominator, that is sec theta plus tan theta upon 1, which is equal to sec theta plus tan theta, and this is our RHS. Hence proved. Okay.